First test you need to do is kind of your overall F-test, and in fact, that's what I call it. And I stress overall F-test. This tests the whole model. So, in the last chapter, we only have one predictor. So our entire model, all right, this is an easy question. We had one predictor. So how many X variables do we have in our model? One. So testing the whole model was equivalent to just testing that one predictor. That's why I didn't teach you both tests last chapter. But now we have the entire model, which has two predictors in it. So first, we need to test the overall model. And if we get the right result in the overall model test, then we will go down here and test each of these individually. But first, we need to do our overall model test. Now, I'm actually going to stop. Y'all might want to write this, and I'm not saying this is important for the test, but I can't believe I'm going to utter this phrase. I'm not going to do 7 steps. There you go. There really are 7 steps here, but I think we're to the point now where we don't necessarily have to do all 7 steps. And we kind of started doing this in regression last chapter. On your test even, I told you toward the end, you don't need to do all 7 steps, but I did tell you write down HO and HA and tell me your results. So let's just think about doing that. So if we want to test the overall model, how many predictors do I have in this model? 2. I've got house size and then setback, right? So I've got 2 predictors in this model. So my HO for this test, because I have 2 predictors, my HO for my overall model test would be that beta 1 equals beta 2 equals 0. Now think about this. Y'all did this on the test you just took. You tested, I can't even remember now what the thing was, the restaurant price and the score of the restaurant.
Quality versus price.
There was an LSD thing that had to do with that. We had a regression question that had the price of the restaurant and their score on this health inspection.
Oh, yeah.
And y'all were supposed to do a hypothesis test of that, and your HO and HA would have been beta 1 equals 0 or beta 1 does not equal 0, because you only had one predictor. Now I have 2 predictors. So my HO is that beta 1 and beta 2 both are 0. What are these beta? This is the true slope for x1 square footage. So what would this beta 2 be?
True slope,
The true slope for setback, right? It's the true slope coefficient for my second variable. So this is the true slope for that setback variable. So my HO is saying both of these, the house size and the setback variable, both of them have a slope of 0. So what would that mean? If that's true, what does that mean about the 2 variables in your model? So they are not related to price. If both of them have a slope of 0, that means neither one of them has anything to do with the price of the house. Just like it did last chapter. If the true slope is 0, that means there is no relationship between our x's and our y. So if that's true, what does that mean about your model? Your model is useless. If HO is true here, you need to just throw this model away. Well, what's your alternative hypothesis going to be? That would mean both of them are significant. At least twice, like ANOVA, right? Either they're all 0 or at least 1 beta is not equal to 0. What would that mean? At least one of your predictors is significant. So we basically have 2 options here. HO, my model is junk. Nothing in my model is related to price. HA, something in my model is related to price. I don't know what, but at least one of the variables in my model is related to price. Now, of course, when we were doing this before with ANOVA, we started with sums of squares, we got degrees of freedom, we divided, we got this, we got this. We're to the point now where we can just use computer output. And let's say we're testing this with alpha 0.05. So the p-value for the overall analysis, and remember or make note, this analysis of variance test is testing my overall model. Is anything in the model significant? That's the first question I need to ask. And the way I answer that is I simply look at the p-value. And what do I do with that p-value? Compare it to alpha. That p-value is less than this alpha. So what would I do? I would reject. You reject if the p-value is low, remember? The p-value is less than alpha, so I reject HO. All right, here's where we're gonna have you're gonna make me proud. What does that mean about my model? At least, and what does that mean? At least one is not zero, so at least one of the variables in my model is related to price. So I have to do this first test. It's kind of my gatekeeper test. This is testing my overall model to see if there's anything worth investigating in the model. And if you reject HO, that's telling you, yeah, something in your model has some relationship to price. Now, what is your obvious next question to that? Which one or which ones? That's your follow-up tip. This is your, like I said, it's kind of your gatekeeper test. You have to do this one first. If you reject HO, then you go on to that follow-up question, well, which variables are significant? And where would we find that? Ma'am? And down here in the coefficients table. Down here is where you're going to test the individual variables after you do your overall model test. So first you have to test the overall model. If you reject HO, then we follow that up with the, well, which ones? So y'all sort of okay with the overall test here? We'll do more of these, trust me. So we did our overall model test. Now we want to follow that up by testing the individual coefficients, or my individual, I'll just call this my individual variables, my individual predictors. This is where I figure out which ones are significant or not significant. And again, we almost never care about the constant. I mean, if you want to interpret a constant, you almost never do. But the way you would interpret that, this would basically say, if you're looking to buy a house that has 0 square footage and it has 0 setback, that house would cost negative $21,284. Well, that's just that's a stupid, we don't care about the constant. It's just in there to make it fit better.
Do we need to know what it means?
I don't think so. It's the best answer I can give you right now, sorry. We're almost never interested in the constant term. So for the most part, we can kind of ignore it. We are very interested in these two though. Those are the things I want to know about. Are these things significant? So technically, we would have two different HOs and HAs here because we have two different variables to test. So if I wanted to test square footage, beta 1 equals 0, beta 1 does not equal 0. If I wanted to test setback, beta 2 equals 0, beta 2 does not equal 0. And if we're testing both of them at 0.05, let's say, again, I'm not going to drag you through 7 steps. We're to the point now where I think you can do this without 7 steps. What do we really need to test these two to see if they're significant? The p-values that go with square footage and setback. So really, all we need are those two p-values. So based on this coefficients table here, and those two p